Howdy and welcome back. So we'll go ahead and close out today's, one of today's lessons, I think, with passing two-dimensional arrays to functions. Now, these two ways are going to be equivalent. It's just one of the two I find a little bit more informative if I'm reading through the code. Recall, though, that arrays do not know their size, and two-dimensional arrays do not know either of their dimensions. So in both of the kind of flavors of argument passing that you're going to see here, both are going to have parameters that are going to store the number of rows and the number of columns for our array. Now, the two functions that I'm using to illustrate this are doing two different things. The function on the left, which I will say is going to be the preferred way of passing a two-dimensional array in this class, is simply going to initialize each element of that two-dimensional array to the zero value of the type by default, or whatever value is specified when this function is invoked. Now, the function on the right is going to have the less preferred way of passing a two-dimensional array to a function. Print 2D array is simply going to be a function that's going to take in our two-dimensional array, number of rows, number of columns, and then optionally a stream that we'd like to print to, as well as a delimiter on how we'd like to separate each of the values stored within our 2D array. So if we go ahead and look at this, what's the difference between the parameter R in the version on the left versus that on the right? Well, they're equivalent. So why would I prefer the version on the left? Well, if you think about it, R is kind of technically an array of pointers to some sort of row objects, right? So I find this way more descriptive, and this is assuming that number of rows is 3, number of columns is 3, right? Because this to me is just a bit more, I don't know, easy to visualize, and it really communicates that R is an array. It's not just a single single object out there in memory. It's a kind of collection of objects. And that's being communicated with the empty subscript notation after R. Now, this way on the right is completely valid too. It's simply saying our parameter R is a pointer to an integer object. So if we have the same structure, so let's say that here we have a two-dimensional array of that's 3 by 3. With each of the rows all located on the free store as well as R. Notice here that if we just say R is a pointer to an integer, my initial impression is that we have something like this. R points to a pointer, which points to an integer object. Nowhere does it really communicate that R is actually an array of pointers. The version on the left does that. I mean, yeah, you're still, it's the version on the left, you still look at it and go, okay, well, maybe it's just a pointer to a single integer object and not a array of integer objects. But at least we're, kind of getting there in one dimension that, okay, well, it's definitely an, array of pointers to an integer object. So we're halfway there. In the version on the right, we're kind of not even there, because when I'm just reading this, I'm going, what is that? Is it this? Or is it something like, this, where R points to the base address of an array of pointers to integer objects? That's very clear over here. Over here, not so much clear. But both of these are valid ways to pass a two-dimensional array to a function. And again, we'll prefer the version on the left.